Imagine you're watching the night sky and suddenly something that shouldn't be there appears. It's not a satellite. It's not space junk. It's something coming from another solar system, cutting across our cosmic backyard at unimaginable speeds. Now imagine that this has already happened 3 times in the last 8 years, and nobody knows for sure what these things really are. What you're about to discover will completely change the way you see our place in the universe. Because while the whole world is still trying to make sense of Oumuamua, the mysterious cigar-shaped object that visited us in 2017, a new contender has just stepped into the ring, 3I Atlas. And this time, scientists are better prepared for the showdown. The question no one wants to say out loud is simple and terrifying. Are we witnessing natural visitors from other stellar systems, or is something completely different going on? Something that challenges not only our understanding of physics, but our very definition of what is natural in the cosmos? For centuries, humanity watched the skies without ever detecting a single object coming from outside our solar system. Not one. The statistics were brutally clear. 0 confirmed interstellar objects in the entire history of astronomy. Then, in 2017, everything changed. Oumuamua appeared, defied our expectations, and disappeared before we could study it properly. 2 years later, Borisov confirmed it wasn't a one-off event. And now, in 2025, 3I Atlas emerges as the 3rd confirmed visitor. 3 objects in 8 years after centuries of absolute silence. Don't you find that strange? What does that mean for you, for us, for our civilization? If these objects are natural, then our galaxy is far more dynamic and interconnected than we imagined. Space rocks from alien systems regularly cross our territory, carrying information about distant worlds we'll never see. But if they aren't natural, well, then the conversation changes completely. And this is exactly where the battle between Oumuamua and 3I Atlas comes in. 2 objects, 2 completely different profiles, 2 enigmas that could redefine our understanding of the universe. The convenience of believing they're just space rocks runs up against the discomfort of their bizarre characteristics. And the more we look, the more questions arise. Let's start with round 1, the discovery. Oumuamua was detected by the Pan-STARRS telescope in Hawaii in October 2017, but it was already on its way out when we found it. Astronomers had only a few weeks to observe it before it vanished forever into interstellar darkness. It was like trying to study a bullet train by glancing out the window as it roars past the station. 3I Atlas, on the other hand, was initially spotted by telescopes in Chile between June 25th and 29th, 2025. But its discovery story is more complex and collaborative. An amateur astronomer named Sam Dean found the object in old images from the ATLAS system, the Asteroid Terrestrial Impact Last Alert System, which operates telescopes in Hawaii and South Africa. That retrospective find allowed scientists to chart its orbit much more precisely from the start. Here's the first big difference. While Oumuamua caught us completely off guard, already leaving when we detected it, 3I Atlas was found while it was still inbound. That wider time window is crucial. It's not just about having more time to look. It's the difference between trying to perform an autopsy on a body that's already decomposed and examining a patient who's alive and breathing. By the Wednesday following the initial discovery, the Minor Planet Center had already received more than 100 observational confirmations from telescopes around the world. The mobilization was immediate and global. The astronomy community learned from Oumuamua. When an interstellar object shows up, every second counts. Now for round 2, speed and trajectory. Oumuamua entered our solar system traveling at about 87 kilometers per second relative to the Sun. Fast? Yes. But 3I Atlas is moving at around 244,620 kilometers per hour, or roughly 68 kilometers per second. Slightly slower than Oumuamua, but still absurdly fast by any earthly standard. Paul Chodas, director of NASA's Center for Near-Earth Object Studies at the Jet Propulsion Laboratory, stated without hesitation, "This thing is traveling very fast. There's no doubt the comet came from interstellar space. If you trace its orbit back, it seems to be coming more or less from the center of the galaxy. It definitely came from another solar system. We don't know which one." Oumuamua's trajectory was equally impressive. When scientists tried to retrace its origin, they found it might have come from the direction of the star Vega in the constellation Lyra. But Vega wasn't in that position 300,000 years ago, when Oumuamua would have begun its journey. It's like trying to find someone in a city where all the addresses are constantly changing. 3I Atlas, currently located about 3.8 times farther from the Sun than Earth is, has a well-mapped schedule. On October 3, 2025, it will make its first close planetary approach to Mars. Then, on October 23rd, it will reach perihelion, its closest point to the Sun, at a distance about twice that between Earth and the Sun. Earth will be on the opposite side of the Sun during that flyby, eliminating any risk of collision. Its closest approach to Earth is expected in December 2025, just as it begins its final outbound journey out of our system. Compare that with Oumuamua. When it was discovered, it had already swung around the Sun and was accelerating out of the system. We didn't get the chance to observe it at peak approach. It was like showing up late to a show and only catching the end credits. Round 3. Shape and appearance. This is where things get really weird. Oumuamua displayed an extremely unusual shape, described alternately as a long cigar or a flattened pancake, depending on which analysis you prefer. Its aspect ratio, the proportion between length and width, was at least 5.1 and possibly up to 10.1. Nothing remotely like that had ever been observed in space before. Think about it. Asteroids and comets are usually rounded or slightly irregular because gravity and impacts over billions of years tend to smooth out their shapes. A naturally elongated object with that ratio challenges our understanding of how celestial bodies form and evolve. 3. Atlas, on the other hand, is still a visual mystery. Scientists haven't nailed down its exact shape, but they do know it's extraordinarily bright. Harvard professor Avi Loeb explained that this intense brightness could mean two things. Either its surface is highly reflective, or the object is huge. If its surface were as dark as a typical rocky asteroid, 3I Atlas would need to be between 12 and 20 kilometers wide to reflect that much light. That would make it significantly larger than Oumuamua, estimated at only 100 to 400 meters long, and also larger than Borisov. But here's the fascinating ambiguity. Some astronomers have reported that 3I Atlas may be a comet. If true, that would partly explain its brightness via a coma, the cloud of gas and dust surrounding active comets. That would make it more like Borisov, the second interstellar visitor, which was clearly a comet with a visible tail and typical composition. So we have Oumuamua, dry, tailless, bizarrely elongated, and showing no signs of cometary activity. And we have 3I Atlas, potentially an active comet, but with anomalous brightness. One is a dry, silent enigma. The other is a bright, possibly active enigma. Who wins this round? Nobody, because both defy simple explanations in completely different ways. Round 4, and here we reach the heart of the controversy: anomalous behavior. This is where Oumuamua lands its most bewildering punch. As the object moved away from the Sun, something extraordinary happened. It accelerated. It didn't slow down as it should under purely gravitational influence. It sped up. The acceleration was small, but unmistakable. Scientists measured a change in velocity that couldn't be explained by the gravity of the sun or the planets alone. When comets accelerate like that, it's because solar heat vaporizes ice on their surfaces, creating gas jets that act like tiny thrusters. That's the so-called rocket effect of outgassing. The problem? Oumuamua showed no tail, no coma, no visible signs of outgassing. It was like watching a car speed up with no visible engine. The natural explanations began to sound forced. Maybe it was releasing invisible hydrogen, or maybe its surface was made of frozen nitrogen, sublimating without leaving a detectable trace. Possible? Yes. Convincing? Depends on whom you ask. That's when Avi Loeb stepped into the ring with a hypothesis that split the scientific community. What if Oumuamua was a solar sail? An artificial, thin, reflective structure designed to harness the pressure of solar radiation? That would simultaneously explain its flattened shape and its anomalous acceleration without visible outgassing. Loeb didn't categorically declare it was an alien craft. He simply said, "We should consider all hypotheses, including artificial ones, when the natural ones fail to explain the data." The reaction was immediate and fierce. Part of the scientific community accused Loeb of sensationalism. Another part reluctantly acknowledged that he had a methodological point. Science should explore every explanation compatible with the observations, not just the comfortable ones. And 3i Atlas? So far, there's no evidence of anomalous acceleration. But Loeb is already calling for the James Webb Space Telescope to be pointed at the object specifically to look for non-gravitational acceleration. If they find it, we would have 2 interstellar visitors with the same bizarre behavior. If they don't, that makes Oumuamua even more unique and inexplicable. With Oumuamua, we observed late, oriented quickly, posited multiple conflicting hypotheses, and couldn't act because it was already gone. With 3i Atlas, we're observing early, orienting with better tools, and we still have time to act with powerful instruments like James Webb. Round 5. Ability to study and tools available. Here comes the dramatic twist that changes everything. When Oumuamua was discovered in 2017, we had good telescopes, but nothing like the arsenal we have now. The James Webb Space Telescope wasn't yet operational. The Vera C. Rubin Observatory in Chile was still under construction. Our asteroid alert networks were less coordinated and less sensitive. Oumuamua caught us technologically unprepared. It was like a boxer stepping into the ring against an opponent who's already warmed up, trained, and wearing better gloves. In 2025, the situation has completely flipped. James Webb is fully operational and capable of detecting chemical compositions, surface temperatures, and even searching for complex gases in distant objects. The Atlas system that detected 3i Atlas now operates with dramatically improved sensitivity, and the Vera Rubin Observatory is about to start operations, promising to scan the entire visible sky every few days. Now that we finally have the tools to study an interstellar visitor properly, Oumuamua has been gone for years, silent and unexplained, traveling forever through the galaxy, carrying its secrets. And 3i Atlas is here, available, observable, but it may end up being just a normal comet without the mysteries that make Oumuamua so fascinating. So who's really winning? The mysterious object that escaped before revealing its secrets, or the object we can study that might not have secrets to reveal? Round 6. Context and frequency. Before 2017, no interstellar object had been confirmed crossing our solar system. 0. The absence was so absolute that some scientists even questioned whether such objects existed in significant numbers at all. Oumuamua shattered that paradigm. Its discovery forced a full reassessment. If we found one interstellar object with the limited technology of 2017, how many must be slipping by unnoticed? Estimates were revised drastically upward. Maybe dozens, hundreds, or even thousands of interstellar objects cross the inner solar system each year, but we simply don't see them because they're small, dark, or moving at unhelpful angles. Borisov, in 2019, confirmed that Oumuamua wasn't an absurd statistical fluke. And now 3i Atlas reinforces the pattern. Interstellar objects exist and pass through here with some regularity. The more objects we find, the more we realize each one is different. Oumuamua was dry and elongated. Borisov was a classic comet. 3i Atlas is bright and possibly cometary, but not yet fully characterized. There's no clear pattern. It's as if the universe were sending us a grab bag of samples with no instruction manual. The goal was to understand interstellar visitors. The obstacle is that each new visitor challenges the generalizations we tried to build from the last one. The scientific community's decision was clear. We need more data, longer observations, and better tools. The consequence? Massive investments in whole-sky survey telescopes and a commitment to rapid response for future interstellar objects. Round 7. Implications and the future. We are entering a new era of cosmic surveillance. When the Vera Rubin Observatory is fully operational, it will detect objects much earlier in their approaches. That means more observation time, more opportunities to study composition, trajectory, and behavior. The calculated ambiguity remains. Are we about to discover that interstellar objects are common and generally mundane, as Borisov suggests? Or will we find more anomalies, like Oumuamua, objects that resist easy explanations and fuel speculation about artificial origins? Here's the foreshadowing we can't ignore. If the discovery rate keeps rising exponentially with better telescopes, we could be detecting dozens of interstellar objects per decade by the 2030s. That would turn an exotic field of study into a mature discipline of astronomy. Robust statistics would finally tell us whether Oumuamua was an outlier or the first example of an entire class of objects we simply don't understand yet. The cultural code here runs deep. Our civilization is cosmically maturing. For millennia, we watched the sky assuming everything up there belonged to our solar system. Now we know we live in a busy neighborhood where visitors from other systems pass through regularly. This shift in perspective is as significant as Copernicus's discovery that Earth is not the center of the universe. And as for the possibility of artificial origins, it isn't going away. Every new interstellar object will be scrutinized for anomalous signs. The artificial hypothesis remains scientifically valid as long as natural alternatives fail to fully explain the observations. It's a tense balance between healthy scientific skepticism and openness to extraordinary possibilities. So, after all these rounds, who wins the matchup between Oumuamua and 3i Atlas? The honest answer is, you decide. It depends on what you value most in a cosmic mystery. If you value pure enigma, the unexplained anomaly that challenges our best theories, then Oumuamua wins by knockout. Its anomalous acceleration without visible outgassing, its bizarre shape, and its perfectly inconvenient timing, escaping before we could study it properly, make it the most fascinating interstellar visitor ever detected. If you value the chance for detailed study, the opportunity to actually learn something concrete about objects from other stellar systems, then 3i Atlas is winning. It arrived in an era of superior instruments, was detected early enough for prolonged observation, and may finally give us solid answers instead of just more questions. But maybe the true victory doesn't belong to any single object. Maybe it's ours. Humanity went from 0 confirmed interstellar objects to 3 in just 8 years. We moved from complete ignorance about visitors from other stellar systems to a growing awareness that we live in a universe far more dynamic and interconnected than we imagined. Every interstellar visitor is a cosmic time capsule, carrying information about solar systems we'll never visit. They're free samples of alien chemistry, exotic orbital dynamics, and distant planetary evolution, delivered right to our cosmic doorstep. There's no reason to fear 3I Atlas or lament Oumuamua's departure. Both are gifts to science, opportunities to expand our knowledge of the galaxy we live in. The next interstellar object may already be on its way right now, still undetected, cutting through the darkness toward our system. When it arrives, we'll be more prepared than ever. And who knows? Maybe we'll finally get the answers Oumuamua denied us. Want to follow this cosmic journey with us? Subscribe to the channel, turn on notifications, and support our work by clicking Super Thanks or visiting our merch store. Every interstellar discovery is a unique chance to witness history being made in real time. In the next video, we're going to explore what would happen if we managed to intercept and land on an interstellar object. Do the technologies exist? Are the missions viable? The answers might surprise you. Thanks for watching, and a special shout out to our channel members for the continued support. See you in the next video, where the cosmos keeps revealing its secrets, one mysterious visitor at a time.